Well, we got us another test here. Hope you guys are getting something out of these things. I sure enjoy putting them together. And this is another 10 question general test. It sort of bounces around from one thing to the other. And so we're going to see what we can do here. Question 1. A vibration comes and goes depending on mile per hour, but is unaffected by engine RPM. Is that maybe a dual mass flywheel out of balance, or prop shaft balance, or worn U-joint, or pressure plate has a broken spring, maybe a collapsed engine or transmission mount? Alright, question 2. A limited slip differential chatters when the vehicle is turning a corner. If it's an outer round carrier, a bad outer wheel bearing, is it ring and pinion backlash, or does it need friction modifier? The vehicle pulls to the right at first when braking and then normalizes and stops straight. Does that mean you need to balance the air pressure on both front tires, replace the left lower control arm, or replace the left front brake hose, or replace the left front strut bearing? On an EPS scan tool live data feed, what is torque sensor data? Does it measure motor current? Does it measure steering force? Does it calculate engine load? Does it measure steering angle? Question 5. The brakes work normally, and then the pedal slowly sinks to the floor while holding steady pressure at a full stop. Okay. If the ABS pump motor is running, does that mean that master cylinder seal leaks, hydraulic booster leaking, or old brake fluid foaming up? Question 6. Why is it important to use a silencer band when machining a rotor? A. Dampens rotor vibration. B. Contains metal shavings. B. Keeps the rotor cooler. C. Keeps the rotor cooler. And D. Protects the carbide bits. Question 7. The battery dies overnight and a parasitic draw test shows 500 milliamps. Is this normal for vehicles with computers? Should the draw be 0 after the modules go to sleep? Is it normal if you're equipped with remote keyless entry? Or should it be less than 50 milliamps overnight? Question 8. The passenger power window only works from the driver's side switch. We replaced the passenger side switch. No joy. Is it a bad ground connection at G301? A bad internal window motor ground? Passenger side switch is still faulty? Or the driver's side switch is suspect? Question 9. The AC always blows cold on the highway, but sometimes, and only sometimes, the belt squeals and the cooling is reduced while in slow-moving traffic. Is this a fan commutator problem, a loose compressor belt, blower resistor failure, or a stuck expansion valve? Question 10. The heater blows cool and the heater hoses are cool to the touch on a vehicle with no heater control valve. Measured engine temperature is 210 degrees Fahrenheit. The cooling system is full. Is the thermostat stuck open? Is it a water pump impeller issue? Are the radiator fans spinning too fast? Or is the AC blend door stuck? Well, let's see what we can do about getting some answers to these things. Now, this vibration, as you see coming and going, if it comes and goes with vehicle speed, like if it comes in at 45 and then it goes out and then it comes back in at 65, you're finding the resonance of an out of balance drive shaft, or you're going to have a worn U-joint, which won't feel exactly like an out of balance drive shaft, but the point is you're going to have a prop shaft balance or worn U-joint issue if you're feeling something like this. And I will tell you something else too. You're not going to be able to determine whether or not you have a bad U-joint unless you take the drive shaft out and feel of the U-joints. If you just look at it with the drive shaft still in the car, you may not even find a bad U-joint that way. But if you pull the drive shaft out, they need to be able to move very freely in both directions. And a bad one will be really stiff in one direction and easy in another direction, when you're bending them throughout their movement. So if the fact that one of the keys is it's based on vehicle speed. If I feel a vibration and I want to see if it's in the engine, I get driving down the road whenever it's safe and there's not a lot of traffic and I'm on a straight road, and I'll bump it up in neutral and switch off the engine and let it keep going at that same speed. If I still feel the vibration, I know it's not engine related, so that's not too difficult. Question 2, limited slip rear end. It needs friction modifier. That's the deal on that one. The friction modifier that Ford makes that you put in these things, it stinks so bad. And I used to keep a little bottle of that stuff on my teaching desk, and I would take the top off of it, and I'd say, no, I actually wouldn't take the top off. I'd pass it around. So I'd take the top off and smell of this, so you'll know what it smells like. And boy, I tell you, that was some stinking stuff. But the interesting thing about that was I had a Taurus one time that was doing a surge. It kind of felt like an EGR surge, but whenever I started monitoring the modulated torque converter signal, I noticed that the surge seemed to match that. And so I realized that, what I really should have done was done a transmission fluid change, but I took some of that friction modifier because I had some in my toolbox, and poured a little bit of that in there, and that cleared it right up. The reason it cleared it up is because the torque converter clutch, as it was modulating 10, 20, 30, 40, 50%, it was not slipping smoothly. It was sort of chatter and slip. On your Crown Victorias, you'll feel something like you're running over those little parallel asphalt strips coming up to a stop sign. It'll feel like that when the friction modifier is gone. That is usually a transmission fluid exchange on those will take care of that. And so that's basically what I should have done on that Taurus. But the first time I ever saw that was on a brand spanking new '89 Eagle Summit. That was the people started noticing the surge on the tachometer first, and then they started feeling it. And the crazy thing about that Eagle Summit was they gave it to me to figure out what was going on with that surge, because typically I was the one that worked a surge out of one. And I cleaned the fuel injectors, and it took care of the problem for about 2 days. And then they came back. And so I worked and worked and worked on that thing, and so trying to figure out what was going on with it. My cleaning it threw me off my game when cleaning the injectors cleared it up, and then the problem came back. So I was thinking, what in the world is going on here? And so I even took some new injectors and put in there, and it cleared it up for a couple of days. Again, and it came back. And so I called this guy named Dave Farley down in New Orleans with Chrysler. And he says, yeah, we've been dealing with that. And he says, what I want you to do is get some Mopar ATF Plus, ATF Plus 4, ATF Plus, whatever it was. And he says, change the fluid in that thing. And it didn't have very many miles on it, but he says, and see if that takes care of it. And I said, that's a bunch of hooey. So we changed the fluid in it, and that took care of the surge entirely. Well, that one needed friction modifier in the fluid, and that Mopar ATF Plus had that. And the Ford transmissions, one of the guys that had graduated from my program was working at a used car dealership, and he replaced the transaxle in a Ford Windstar with a crate unit, and he drove it, and it was they drove it and it was fine for a little while. Then it came back with a sort of a surge, and so because it was under basic warranty as far as the transmission, I told him send it over to Jimmy at the Ford place. So Jimmy at the Ford place, I said, what did you find on that transaxle that was surging? He says it had the wrong fluid in it. And it came from the factory that way. When they rebuilt it, they put the wrong fluid in it. I said, how could you tell? Because I could smell it. Well, the smell of that stuff is different. If you can smell of the fluid that's got the friction modifier in it and tell a difference between that and regular transmission fluid. I sort of took a long time on this slide. I didn't know. Question 3. Vehicle pulls to the right at first when braking, then normalizes and stops straight. If you got a brake hose that's partially clogged, it's going to keep fluid from getting to that wheel initially, but if you keep holding the brake, it'll bleed the pressure through there, and the car will begin to pull to the right. But if you keep holding the brake, it comes back to. That's what I was trying to illustrate with that little land art thing, but I really didn't do that good of a job with that. but that's what was going on. That's the first place I'd look, would be an almost clogged brake hose, and you might have seen this aging process as this went through. Those brake hoses, they bend a lot when you're turning. That's why they're there, and sometimes they come apart on the inside. This measures steering force, the torque sensor data. When you're turning the steering wheel, it needs to know how fast, how hard you're turning it. It needs to know, and a lot of times it'll measure steering angle and steering force. So, that distractor there is probably not very good there, as far as that. I got to turn on my laser here. All right, now then, question 5. The brakes work normally when the pedal sinks slowly to the floor while holding steady pressure to full stop. That's master cylinder seal leaks. This is just a little microcosm of that. When the seals are leaking, initially this rubber seal will bite, and then whenever you keep pushing it, it starts letting fluid leak past, and this goes forward because it's trapping pressure in front of this. As the pressure leaks past this into the back of it, then you're going to feel the pedal go to the floor. Then you'll let go of the pedal and hit it, and it'll stop again, and then it'll go down like that. But sometimes, in rare cases, some of the ABS valves can cause that, but that's almost never the case. It's important to use a silencer band because it dampens rotor vibration and keeps it from going and making little, chattering marks on the rotor. Now, you might notice this one I'm showing the video of was one that we had. This one didn't require a silencer band, and the reason that particular unit doesn't require a silencer band is because the cutting bits, while you're doing the cut, are making little circles in addition to machining, they're making little circles the whole time, and it's causing a non-directional finish, and it keeps it from needing to have any kind of a silencer band. So this particular on-car brake lathe, not all of them do that. A lot of the on-car brake lathes still require you to put a silencer band on it, but this particular one didn't. It was one that I paid $12,000 for that when I put in that new. I started a new automotive program in a town up the road, and we bought this one here, and this is a really, really good one. Question 7. Battery dies overnight. A parasitic draw test shows 500 milliamps. It should be less than 50 milliamps overnight after the modules go to sleep. The reason for that is you got little capacitors in here that have to charge up and everything. And a lot of the time, we had a 2010 Mustang, and we measured a draw that was probably 500 milliamps or something like that instead of 50. And so I told the students, I said, let's put this meter on this thing and just leave it alone. Don't touch it. Just let it sit here. And we let the car sit there a solid hour. And after it sat there an hour, that the current it was drawing dropped off to below 50 milliamps. And so we determined that way that we had a bad battery, and on that particular one. But the simple fact was you could have gone off on a rabbit trail if you measure 500 milliamps and you immediately go looking for that. Well, if you got one that doesn't go away when the modules go to sleep after an hour or so, you basically put your, what I would do is if you've got one of these big fuses right here going to the fuse panel, I would remove that, and I would put either that or put an inductive probe around here, or hook an oscilloscope up to an inductive probe and, let it show you on the screen. And then you start pulling your big fuses, and whenever you get to let's say you pull this big fuse, let's say you pull this big fuse right here, this one here, because it's feeding these fuses here. Alright, so I said, alright, now then, this one here feeds all these little fuses, this one here feeds those two fuses, but let's say pulling this big fuse killed the draw. After all your modules went to sleep, you still had a draw, so you pull this one, it kills the draw, put that one back in place, and then pull each one of these and see which one of them is the draw is going through. You see how that works, and that's you're vectoring in on the draw that way. Question 8. Passenger power window only works from the driver's side switch. Replace passenger switch, no joy. Okay, now this is the thing. you might notice how the driver's side switch is suspect, and I've run into this before. I've had my been kicked around by one that the passenger side power window wouldn't work. I replaced this switch and it still wouldn't work, and it turned out the driver's side switch was causing the passenger side window not to work when all the rest of it worked just right, and even with this switch. But here's the deal. So you got a rail in that switch that's giving you voltage right here. And then you've got a rail here, and whenever you notice, whenever we you can back the video up, you can, whenever this thing goes to lower the windows, let's say, both of this is ganged switch goes over, and this stays on ground, this goes over to power, right? All right, so this goes down here through that. All right, so but when you release this, let's say it comes back up here and you've lost your ground going to this switch down here. So if you let this come back up here and that ground goes away, see, because that ground is still required when you're going to the, when you're using this switch right here. So when you're using this switch down here, it has to get a ground through this normally closed contact in order to operate the motor. If it doesn't have a ground, it's not going to. So what I taught my students to do was you go over to the switch on the passenger side, and you find the wires coming from the other switch, and you want to measure to see if there's a ground on both of these wires when the switch is at rest. When all the switches are at rest, you don't see a ground here, you don't see a ground here, and I'm between the two switches, you see. All right, and then I go to this switch up here and I measure here and here. If I don't see a ground here, I know this switch is bad. If I do see a ground here, but I don't see one here, I know I got a problem somewhere on this circuit here. That's not rocket science, but you just basically need to think while you're doing stuff like that. Question 9. The AC always blows cold on the highway, but sometimes the belt squeals and coolant's reduced in slow-moving traffic. See, this is not an all-the-time problem. It's a fan commutator issue. And I've talked a lot about this, but this is a Nissan fan, which looks kind of complicated because it's got these 4 terminals in it. This represents the commutator, and each one of these is a brush. Okay, that's the way that they draw it in engineering. All right, so I figured out, I got the pin out on this Nissan motor. This was on a van we worked on. And so you connect the test light through the motor, so that it's going through these brushes, through the commutator, out the commutator, back over here to ground. And then you turn the fan by hand. You don't do this with the key on, you do it everything off. You get it even with the fan disconnected, and you're connected right here in the connector going to the fan. You turn it through. It doesn't matter if you go to 1 and 3 or 2 and 4. See, as long as you're reading through that commutator, it doesn't matter which of these terminals you go to as long as you're on 2 of them. All right, so if you turn it through and that light ever goes out whenever you're turning that thing through, then you know that you've got an open spot on the commutator. If it ever stops on that spot, that fan will not come on. Now when you drive it and the wind blows the blades a little bit and it moves the motor, next time it may come on. So anyway, that's my go-to on that. I discovered that all on my own when I was working at the Ford place, and I think it was in 1994 or 5. There was a tempo that would stop down at the traffic light, and it would blow the pop off on the AC compressor like that because the head pressure was going up too high in the condenser because the fan wouldn't come on. They bring it in there, and I would set it there in my service bay, and it would run and kick, run and go. It would kick on and off, on and off, on and off, on and off. And I said, well, I don't know what's going on there, but it's got something to do with the fan. And so I said, well, let's just check this. And I came up with this method of doing this, and unless somebody has seen it on one of my videos or I taught them to do it, you're not going to see anybody else do this. I've never seen this at a school I've ever been to. I just came up with this notion, and it works. It's a go, no go. I like a go, no go test. I like a test that whenever it fails that test, you're done. Put a fan on it. There may be other problems, but if it fails that test, it doesn't matter what the other problems are. You cannot trust that fan. That's the point. All right, the heater blows cool and the heater hoses are cool to the touch. All right, you might notice this is rusted out, and it's got a lot of space between the reaction surface there. This one here, that little aluminum bushing around there had let go, and it was letting the impeller spin. If the water pump's not working right, you're not going to see any heater, any juice going to the heater. Remember I said the coolant system was full, the engine temp was 210, and oddly enough, it won't always overheat. The engine won't always overheat, but the first thing you'll notice is that despite the fact that the engine is running at full temperature, then you're not getting any coolant. And I remember I told you I take both heater hoses loose from the heater core, and I put a clear hose like you buy from Ace Hardware or somewhere, you know, put it in there so you just, this is a temporary thing because you don't have to, you know, and fire it up and look for coolant to go screaming through that clear hose. If coolant doesn't go through that clear hose, and that's how I've always found this, you say, well, the next place we need to go is the water pump. I saw that one that I put in one of these things. It was a 4.2 in a 97 F-150, and it would run at 210 degrees if you let it sit there idling all day long. But when you went to drive out of the service bay, it would immediately try to overheat really fast. I'm talking about before you went 50 feet. And when we took the water pump off of that one, the impeller had come off the water pump. It had rusted loose and come off, and it was just laying there. Now, how that thing ran 210 degrees without the water pump impeller in place, I have never been able to figure that out. But one way or another, that's something that I saw in real time. Well, that winds us up. We've been here 20 minutes and 27 seconds, and let me know what you guys think about this and if you got anything out of it, and I really appreciate you tuning in. We'll see you next week.